Hi all, this is Param. This is a new playlist, okay, obviously. So in this playlist we are going to see how the machine learnings can be leveraged within the Elasticsearch, okay. Sorry, okay, machine learning has a lot of jobs, right? Machine learning has a lot of jobs, okay. In fact, a lot of variety of jobs, I would say, okay, like computer vision, natural language processing, okay, and prediction, bots. There are many things are there, okay. So there are large number of large type of machine learning jobs are there, okay. But within the Elasticsearch, sorry, we are supporting four type of machine learnings. One is anomaly detection, outlier detections, okay, regression and classification. So these are the four type of machine learnings we can run on Elasticsearch. Okay, that means these are implemented within the Elasticsearch. Okay, we are just going to use those machine learning implementations, okay, and passing appropriate data and parameters or configurations, okay, and we can see the output. That's what. So obviously what is now, we are not going to write anything, okay, we are not going to write anything. So we are going to use those jobs, okay, jobs, and pass the parameter and index data. Okay, then we can see the analyzer, we can see how it has run based on the metrics. Of course each machine learning provides some type of metrics, right? Okay, so we will see how those things, okay, in later, okay. And so statistically this can be classified as unsupervised machine learning and supervised machine learning. What do you mean by unsupervised super machine learning? So there is no training data, okay. That is what, there is no training data. Let me put capitals, okay. There is no training data. If it is there is no training data, that is what, unsupervised data. Supervised machine learning means, okay, see, we use the training data, okay, we use the training data, okay. So that is what. So based on the training data only, it has been classified either it is a supervised or unsupervised machine learning, okay. So kind, okay, which group or which category, that's what, okay, with respect to machine learning, okay. So technically all these four are supported by the Elasticsearch, just machine learning, okay, but they are classified either supervised or unsupervised. So it is based on the either you are using training data or not, that's what, okay. First thing. Second thing is, okay, this is one category, okay, you can logical group, okay. So for unsupervised we have two, anomaly detection and outlier detections, okay, anomaly detection and outlier detections. And supervised learning means obviously we are using training data, okay. So set of training data to train our model, okay. So there is a classification and regression. So these two types are there, okay. Now this is one type of category. Now how the data feed, okay, how the data feeds, okay. I mean, how the data is given to the actual machine learning, okay. So if you are if you are using data feed is one of the technical term, I would say, within the Elasticsearch, okay. I don't know about the actual normal theory, okay, but within the Elasticsearch there are two type of data. One is data frame analytics and another is data feed, okay, data feed and data frames, okay. So data feed used only in the anomaly detections, okay. Data feed used only in the anomaly detections, okay, and data frame used by outlier detection, regression and classification. So based on how the data are there. So okay, what is the difference between these two now? Okay, if it's data feed, that is time series data. Oh, okay, what do you mean by time series data? Very simple. Each event or each document is identified with a timestamp, okay. Whereas data frame is entity centric, okay, or entity centric. That means if every entity will have some value, right? Every entity will have some ID. Okay, if just username entity means obviously every document is identified with the user ID or username, right? That is what we will say, like entity centric data, right? So it is kind of table formats, okay. So data frame is kind of table formats. Of course, it is entity centric, okay. Entity centric and it's kind of table format, okay. Okay, fine. Then outlier, okay, outlier, classification, regressions, all are, I said, all are running as a batch. Yes, it is not real times, okay. This is not real times, it is running as a batch data, not real time data, okay. It's running on the batch of data, okay. not on real time data. Okay, so we are giving a batch of data. Okay, so that means what? Why I am saying batch of data? Very simple. See, by default, Elasticsearch data will be pushed into Elasticsearch, right? That is not table format; it's columnar fashion, sir. Okay, or key value fashions. Okay, kind of okay, but data frame is kind of more tabular format. So tabular format means your data, your index data has to be transformed as a tabular data. Okay, then only then only it can be useful for this data. So that's why it is not real time data that I am saying. Okay, so real time data. See, what do you mean real time? With respect to Elasticsearch, it is a second. Okay, within a second, even 1 second, I think 1 second, right? So that is what real time data with respect to Elasticsearch. Okay, forget about other tools or other technology or other frameworks. Okay, with respect to Elasticsearch, real time means it is within the 1 second. But here in the Elasticsearch, we are working on the non real time data. I mean, for outlier detection, regression, classifications. Okay, so obviously how it is a entity centric data, how it is transformed from index to here by the transformations. Okay, so I can put that also. Okay, it will be more easy to understand anyone. Okay, so let me put here. It is index data, so it is transformed. Okay, so let me put here transformation. You can say it's kind of UTL jobs. Okay, transformation, FRMEA. Okay, it is kind of ETL jobs. Okay, so data is by the transformations, it is moved to the data frames. Okay. This is what very important. Okay, so data frames is working on the non-real time data. So obviously it is transformations is jobs. Okay, by transformation jobs, I would say it's a transformation jobs. Okay, we have to create transformation jobs. Okay, in the Elasticsearch, that will convert the index data into the data frames. Okay, in fact, the transform, there are two type of jobs. One is pivotal, another one is incremental. So okay, we will see later. Okay, in detail what is that. Okay. Okay, so with respect to the data format, I have okay. Now, if it is anomaly detections, okay, if it is the anomaly, if it is anomaly detections, okay, it must be the time series data. So that's what it must be time series data. Okay, but these kind of for this kind of data, I mean data frame analytics, that is not time series data. That is okay. That is not time series data. It's entity centric data. Okay. Non-time series data, that is entity centric data. Okay, okay, fine. So format of data. Okay, now what it can do. Okay, then how again one more classification, one more difference. Okay, let's see. Here we are saying supervisor, right? So obviously we are using training data, right? Okay, then how these two are different. Okay, okay. So regression, what will it is continuous. It is continuous and numerical values. Yes, both are used for the prediction only. Okay, both are used for prediction only. Okay, so let me put underline here at least. Both are used to prediction only, but what it predictions? Okay, what happened? Okay, what it predicts? So that is what difference. Okay. The regressions we are to continuously and numerical values. So that is what regression. Here discrete and categorical values. Okay, so discrete and categorical. Okay, categorical values. So this is what it prediction. So these two do the prediction. So what is output of the supervised learning means to identify the prediction. Identify the prediction. Okay, identify the predictions. So the purpose of supervised learning, purpose of supervised learning is for just for purpose of the supervised machine learning to identify the predictions. Okay, but here it's just a kind of analysis. This is different. Okay, okay. Then technically, okay, technically how these are happening is happened, okay. We can say like here, even if you are new to data science something, they will say, of course, see, machine learning in fact in behind the scene it is using data science, right? Obviously, data science or data analyticals, okay. um, just give me a second. Sorry. Okay, what I was discussing, I forgot. No problem. That is fine. Okay. Data feed. Yes. How the things are defined. Okay. In the data. Yeah. What I was telling now. Data science. Okay. Data science or data analytics behind the machine learning jobs. It seems behind the jobs. Okay. So of course we have to prepare the data and we have to do the selection. Okay. Selection of features. Feature means nothing. One or two column. That's it, sir. Okay. So what are the fields we have to use? That's what. To build the model. Okay, so for the analysis, what are the column has to be taken, and what are the values has to be filled for non value or null values. Okay, that's what these are things. Okay, so here for data frame analytics we will say is a feature. Okay, features based data frames are feature based. You can see here feature fields. Okay, here also feature field. Okay. Okay, so all these things, all these data frame analytics are feature based. Anomaly detection is influencer based. Influencer, then what? How the difference between feature and the influencer? More or less same, sir. Okay, here also we will say what are the fields. Here also we will say what are the fields. Okay, so you don't worry about it. Just the job name or ML job category ML job name is different, so they might have they use a different word. Okay, but technically here also influencer means we will say like these are the fields are used. These are the fields influencer anomaly detections. Okay. Obviously, in prediction also, these are the fields participate or impact the prediction. That's what. Okay, fine. So anomaly jobs run continuously. Is a batch jobs. Okay, work on the batch. Okay, work on the batch. Okay, so that's why here is data feed. Here is data frame. Okay, data feed, even if data feed is synchronized, it keep on coming. Okay, it's keep on coming. Okay, that's what anomaly detections. Okay, so what is the use case then? Okay, then what are the use cases? Okay, fine. Anomaly detections mostly, since Elasticsearch is the what? Elasticsearch is kind of operation DevOps tool, right? Okay, operation monitoring tool predominantly. Okay, Elasticsearch can be used in many other purposes also. It can be used as a search engine. Okay, it can be used as a data store for JSON or or semi-structured or non-structured data. Okay, it can be used as a search engine. Okay, like Google engines. Okay, within the organization, that is what enterprise workspace. Enterprise search. I think. Yeah, enterprise search. Sorry, enterprise workspace, right? Yeah. Okay, enterprise workspace, I think. Okay, okay. So it can use as a search engine. But mostly what is the data? Mostly as per my experience I am saying, so they will get the operation data. Okay, either from Beat, either from other tool, or either from API. Okay, so mostly data are ingested in the Elasticsearch. Those are related to the operation side, how the memory working, how the CPU working, how the logs are there. Okay, how often you have CPU is happening. Okay, how long it taken with the request. Okay, or what is the infrastructure usage. So what are the events are happened, or any process monitoring, let it be anything. Okay, all these are kind of monitoring related data. Okay, so those data is pushed to here. Okay, so based on but business data very rare, sir. Okay, business data very rare. But I cannot seen like any use cases. We are going to, of course we can. That is different. Okay, we can. But majority application of Elasticsearch monitoring section only. Monitoring server, monitoring application, monitoring services. Okay, so monitoring as Windows event or Linux or okay, audit on the Windows, audit on the something, audit on the Linux box, or checking the performance of a database. So these are this is how. Okay, this kind of monitoring data is only pushed into Elasticsearch. So that is nature of the data, right? That is not nature of the data. Okay, then the predominantly people concentrate on the machine learning, so the anomaly detection. Okay, so the The miniature of anomaly detection is watcher, very simple. Okay, I will have to create this one. Okay, the miniature of, okay, what is shape I can use? This one, right? Yeah, good. Okay, let me put here. Nature of anomaly detection. Using machine learning, watcher is miniature of anomaly detection done by ML. Okay. So, because of I asked the vendor itself, hey, what is the difference when I was beginning of this machine learning feature, machine learning use case, okay. So, I was wonder then what is the difference between anomaly detection and watcher, okay, both are same, right? This, even I asked this question, they haven't replied, okay. So, now I am realizing, okay, watcher also is kind of anomaly detection only, but it is miniature, they are simply, the detection happened by simply by query, right? Yes, watcher is simply by the query, but machine learning what is now? Okay, machine learning use the data statistic, right? Done by machine learning bracket statistic analysis. Okay, statistical analysis, and that is what machine learning. Okay, but watcher simply by the query. Query, right? So, that is why I am saying watcher is a miniature, okay, miniature, I do not know spelling is correct or not, okay, miniature of anomaly detection done by ML. In ML we are using statistical analysis, okay. In the watcher we are using query, okay, query or condition, okay, condition especially, okay, condition, okay, condition and query. Okay, okay, I don't want to bold, okay. Okay. Okay, so now we are clear about the watcher results. Okay, so that is what mainly we will be using anomaly detections most of the times. Okay, most of the use cases are dependent on anomaly detection. By default, anomaly detections can enabled on two set of data. One is SIAM related data, another one is log data. So log obviously time series data, okay, and SIAM data. SIAM is like security analysis, right? Okay, so that also for these two already anomaly detection are implemented, so you can just use that. Okay, so if let's say if you are using anomaly detection, that means I mean, if you want to use a statistical analysis, let me tell you like this way, if you want to use statistical analysis for anomaly detection, okay, you can do the anomaly detection by the query as well, query and condition as well, using the watcher. But if you want to use the statistical analysis, okay, as a data science method for the analyzing to identify the anomaly detections, you have to the source, the data has to be time series data. As of now, it is as of now Elasticsearch support on the log data, APM data, APM data and APM data, then what APM data and SIAM data. Okay, for these two only anomaly detection supported. Okay, so remaining things are data frame analytics. Okay, we will be transform as per our use case. Okay, as per our use case, let's say the index can have n number of data and n number of fields. So whatever the need, okay, based on the use cases, we will be transform the index data to the data frame. Then we will apply an outlier detection or classification regressions. Okay, we will see the later. Okay, so this is what I want to tell you high level. Okay, at the high level how the Elasticsearch support machine learning. Okay, machine learning jobs or use you can say use the machine learning jobs for the scientific analysis on the index data. Okay, thank you, thanks for watching.